Hello and welcome to day 14. Today's input is a bunch of rocks. The big O's roll, the hashes don't roll. We're going to tilt the entire thing forward so all of the O's basically roll until they hit the top line, or they hit another O, or they hit a hash. So after one roll, it looks like this, where all of these kind of go bunch up to the top, like these get stuck on this hash up here, and that's it. To figure out the totals, basically anything on the bottom row is worth 1 point, 2 points, 3 points, and then like the top row, each of those O's is worth 10 points. So the actual coding portion itself, I decided to break everything down into a couple helper functions. So I have one function for rolling. Basically for every column, we're going to keep track of the highest option, and then if we hit a hash, then we just set it the next available spot to below the hash. If we hit a rolling rock, then we replace the rolling rock with a period, and we move the rock to the top section, or whatever's the next available slot, and move the slot up by 1. So pretty simple on that. And then on for counting, basically for each row, I'm going to count how many O's there are, multiply it by that row's weight. Easy enough. So then just calling them is basically just the count function of the roll function output. And then, mapping the input to a list. Pretty simple. I'm assuming that's not why you're here. So part 2, of course, we got to either make things more complicated with more rules, or more difficult to figure out computationally. This one's kind of a 1 and 3, I guess. So what we're going to do is we're going to roll not just north, but north, west, south, and east. And we're going to do that cycle, all 4 of those pieces, a billion times. So 4 billion different types of rolls. Right off the bat, this feels like something that you're going to hit some sort of cycling in. So in my actual one, basically what I did was, well, first off, I made a new roll south, roll east, roll west. And those are basically the same thing with slightly different logic each time, so that we roll in all 4 directions. And then I made a cycle function, which basically just rolls north and west and south and east like they've asked us to, and returns that as a grid. And then for the actual problem, I just basically output that and look for cycles. So like if you look through here, you'll notice that after some amount of time, you're going to get into repeats. You can't be a billion unique cycles in there, right? And so I just kind of printed all this out, and then I just manually found where the repeats were, and then did the math and shoved it in there. But to do it actually correct, I went through again and I changed it. So basically what we're going to do is we're going to keep a list of all the ones that we've seen in the hash map. And so we're going to keep cycling over and over and over until we get to a board that we have seen before. And once we get to a board that we have seen before, then we're going to start the cycle. So we set that to our original, we add that first one to our list, and we just go ahead and get the count for that one right now. And then basically we're going to go through and complete that cycle over and over again until we get to the original one again. And so now we've got our complete cycle, which in my case was in the 20s of steps. So at that point, now I know I've used X amount of steps. And then from there, it's basically just doing a math problem of how much, or what the total one is, minus our base cycles. So like how many steps away we are, and then modulo that by how big our cycle size is, and then looking that up by our list that we've already come up with. So if we do it that way, the problem actually runs really fast. So 138 milliseconds. But basically you can see that I got to my base cycle after 144 times, and then my cycle length was 22. And so we'll just take a billion minus 144 and then modulo by 22, and then go look up what the count was for that position in the list. Anyway, hope it makes sense. If you got any questions or comments, of course, hit me up. The newest code will always be on the GitHub. And other than that, I'll see you tomorrow.